Unlock your potential with these free classroom resources. The knowledge you need is right here.
All right, welcome back. Today we're going to talk about access control in our class, Access Control 101. So let's talk about what access control is. Access control defines who the person is, are they allowed to enter, where and when they can go, and then most importantly, can we prove what happened afterwards? You'll hear us refer to the secure and unsecure side of the door during this presentation. The secure side of the door is the protected side. This is usually considered the inside. You have to pass through a barrier in order to enter to get to the secure side. The unsecure side is generally going to be called the outside. This is where the keyway is, or a card reader. This is the space, the public space often, where you are. So the unsecured side is the side with the card reader, and the secured side is the protected side on the inside. You'll also possibly hear us reference door handing. Door handing is very important when you are ordering hardware. And this is a very handy chart. There's several of them out there. You can just Google door handing chart and you will find ones just like this. And so every door is handed in either right hand reverse, or left hand reverse. And it's a matter of which side of the hinges you're on, which direction the door swings, and basically where the hinges are, how the door swings, and which side you're standing on. So in this particular picture here, you'll see a dot in each of the pictures, and that indicates where the key is. So that's the unsecured side of the door. So for example, a right-hand door, if you were to put your back up to the hinges, it would be the same side that your right arm would move if you swung your arm into the secure space. Conversely, the left-hand door, if you were facing the other way, would be where you swung your left arm. When the door swings out, which is more common in a commercial environment, that's where you get a reverse. And so in that case, the right-hand reverse swings more like how a left hand does, but it still is considered a right-hand reverse because of where the hinges are. And the same is true for a left-hand reverse. You can also have pairs of doors, and in that case, you could have a left-hand reverse and a right-hand reverse in the same doorway because you have two doors swinging two different directions. So like I said, handing is going to be determined by which side the hinges are on, which direction the door swings, which side you're standing on. And this is important to know because if you order incorrect handing, you get incorrect hardware, and then you get a failed installation. Let's talk a little bit about the types of doors. So you have a single door, double door, dual egress, egress only, sliding doors, and roll-up doors. Single doors are just what you'd think of, right? It's a single door by itself. It might be like the front door to your house or the door to your office. It's one door that swings in a frame and it latches against the frame. A double door is a little bit different because it's two doors and they may latch to a post in the middle, or they may latch with some vertical rods, which we'll talk about later. But it's two doors that, that swing the same direction. A dual egress door, however, is two doors that swing the opposite direction. And you most commonly will see these in, say, a hospital space, where security isn't the concern as much as keeping different areas separate for air and everything else. And so in that case, if you have a dual egress door, if you were facing it, one door would be a push door, usually the one on the right, and one door would be a pull door, usually the one on the left. And if you were to hit an automatic operator on that door so that, motor turn those doors, one would swing each way to give you a full opening. Egress only doors are typically, if you're in a warehouse or someplace where you have fire exits or emergency exits, an egress only door is not going to have any exterior hardware on it. It's not going to have any way to pull the door open. It's just a means for an emergency egress to leave an area. And the word egress that you'll keep hearing me refer to is the same as exiting. So ingress is the action of coming into a space. Egress is the action of leaving the space. And most code, if you read it regarding occupation of spaces or ADA or fire or NFPA, any of that, it's going to refer to egress, which is the way that people leave a space. Sliding doors are just what you'd think of. This would be your grocery store, maybe any area where they've got big aluminum doors and they slide to the side. That's a sliding door. And then roll-up doors are often going to be like a dock door, just the same as your garage door at your home. All of these types of doors can be secured. Single and double doors, dual egress doors, egress only, those can all be secured with locks and strikes, crash bars, all sorts of things we're about to talk about. Sliding doors, sometimes you use a lock to secure them. Very often they have what's called an interlock or a chain brake or a belt stop or something, depending on who you're talking to, that's built into the mechanism that opens the door, and it actually locks that belt or that chain so it can't move, so you can't pull the door open. But back to the talk about egress, you'll notice that those doors always have a sign on that says "in emergency, push to open." And so you can actually crash through that door, even though the door won't slide open. If you're on the inside and need to get out, you can actually forcibly push that door and it will swing out. Roll-up doors, often there's the same type of deal, some sort of an interlock inside the motor that opens the door up. You could also potentially have some sort of a magnetic lock to keep them secured. So as we talk about types of locks, a common one is called a vertical rod. And so here's two different types of vertical rods. The first one is a surface vertical rod. And there you can see a couple of crash bars. They have a rod going up and down out of them, and that secures the door to the top jamb and to the floor. A concealed vertical rod is the same thing, except for that the rods are concealed inside the door. Concealed rods are obviously more secure because less hardware is exposed, but they're also ADA compliant. And we'll talk about ADA compliance in a little bit, but one thing to remember with ADA compliancy is that the bottom of a door has to be completely smooth so that someone that's in a wheelchair or has some sort of a walking aid or whatever it is able to push and slide across the bottom of that door and push the door open. So a surface mounted vertical rod cannot go on an ADA compliant door because it violates ADA compliance. And so you may sometimes see a scenario where you have surface mounted vertical rods, but you only have a top rod. And you can actually order most bars like this by ordering them as less bottom rod. It's less secure, but that's often the way that you would do an interior set of doors that don't need the high security of an exterior set of doors. Another type that's very common is called a rim strike or rim lock. To the left is an electrified rim strike. It happens to be the Hess 9600. There are dozens of manufacturers that all make a similar product. They're all excellent. We aren't picking any favorites here. That just happened to be the first picture I came across. And to the right is going to be an exit device, commonly called a crash bar, that has a rim lock on it. And that angled piece that sticks out of the end locks against the gates on the strike. If you push the bar in, the latch retracts and the door opens, or if you electrify the strike, the two gates come free and then you can push the bar or pull the door open in that way. Another type of lock is a mortise lock. These are very common in office doors, slightly higher security. The lock that's on the right there is actually cut in or mortised into the edge of the door, and that entire lock body then slides back into that door. The strike that you see on the left, that's typically going to be used for a mortise lock, and that's considered to be a mortise strike. And the plate that's on there has offsets that are in different places so that you can align the strike and the actual catch there or the latch on the mortise, but also keep the security pin depressed. And so if you see the small triangular piece that's below the latch, if you hold that in, you can't push the latch in. And so by having that little triangular piece pinned in from a plate when the door is closed, it prevents people from being able to slide a screwdriver or some object in there and forcibly open the door. And then another very common type is a cylindrical lock. This is probably the same type of lock that you have in your home. It's pretty common on office doors. They're usually cheaper than the mortise locks, and so a lot of new buildings have these cylindrical locks just from a cost factor. And on the left there is an electrified cylindrical strike. It's the same concept as the mortise lock. The latch drops into that pocket. When you electrify the strike, the gate comes free and you can pull the door open, or if you turn the lever on the inside, then you can retract the latch and go out. For the mortise and the cylindrical lock, if you're ordering hardware, besides handing, you also need to know the function type. You always want to order a storeroom function lock if you're doing access control. The storeroom function lock means that the inside is always free, so people can always egress, they can always leave the area. That's part of fire code. The outside, though, is usually rigid, and that means you can't turn it unless you insert a key. And so that keeps people from being able to turn a thumb turn or put a key in or do something to physically unlock the lock. Instead, as soon as you remove the key, the lock automatically relocks, and so that way that door is always secure. There's also mag locks. Mag locks are thankfully becoming less common than they used to be. Mag locks were the go-to for a lot of people because they're easy to install. Unfortunately, they're also a pretty massive fire hazard. And so in this case, you have a device that when you send power to it, then it energizes a magnet, and the magnet's in that body holds that plate that's attached to the door, and you have an extreme amount of force required, usually about 600 pounds up to 1,200 pounds, that's required to pull those two plates apart. They are very high security typically, but unlike the other locks where you can always get out, a mag lock you can only open if you drop power to it. And so if for some reason power will not drop to that mag lock, for whatever reason, maybe the sensor was put in wrong, the release button was put in wrong, it's just got a failure, who knows, you will have people trapped inside. And that's why generally people don't use mag locks anymore, and there's actually some jurisdictions that won't allow you to install a new mag lock because of the life safety. And life safety will always trump security when it comes to consideration of hardware. So when we talk about this, mag locks are considered fail-safe, and that if they lose power, they become unlocked, and so then the door is unsecure. That's actually a problem, because if you have a power outage, even with battery backup, if the power outage is long enough, your doors will be unlocked. There's also no true free egress. And so that's where I talked about your local jurisdictions may have other policies on whether or not you can even install a mag lock because you can't get them out. Everybody's going to argue on what an FPA says, what local jurisdictions say, so I'm going to tell you my opinion, which is that every door with a magnetic lock should, at a minimum, have a request to exit sensor and a push to exit device and a fire alarm connection. And so that means that if someone walks in front of the request to exit sensor, then the lock will unlock. If someone pushes the push exit button, it's going to mechanically break power and the lock will unlock. Additionally, with the fire alarm connection, if the fire alarm goes off, then it's going to break power and the door will be unlocked. From a life safety standpoint, that's the best way to do it. From a security standpoint, obviously it's not, which is why we try to avoid using mag locks if possible. You'll also see what's sometimes called a shear lock. And so instead of the lock I just showed you where the two faces hit when the door closes, a shear lock is actually in the top jam of the frame and the plate is in the door, in the top of the door, and it pulls the plate up to the top of the frame. Those are common in doors that are all glass that don't have enough room to adhere a plate to the side. So back to the ADA compliance we mentioned before. Anytime you're going to install hardware, card reader, any kind of a push button, intercom, whatever, the maximum height for a device for the part that you have to interact with is generally going to be 48 inches. This could actually be lower based on the reach angle, and so you really need to consult your local ADA and the national ADA guidelines to make sure that you're installing this correctly. Access control systems cannot prevent ADA operation. It doesn't mean that you can't lock a door. What it does mean is that if you have access control on a door that also has a handicap operator or an ADA or a motorized operator, the exterior button has to work when the door is unlocked. Now, you can disable that button while the door is locked, but once the door becomes unlocked, the exterior button has to work. On the flip side, if you're leaving because you have to have free egress, the interior button to open the door has to always work. That means you have to integrate that button into the access control system so that the button not only opens the door, but also unlocks the door. And this is where, obviously, your customers are hiring you because they need a professional integrator to make this work. Some other code that's good to know if you happen to have a spec in opening is that the minimum is 32 inches wide and 80 inches tall. There's a lot of doors out there that are less than 80 inches tall. But that's actually what the ADA code is. Also, no more than 5 pounds of force to open a door. So these guys who are cranking up the door closers to force the door to slam shut are actually not in compliance with ADA code and could easily be sued for that. You also can't have more than a half-inch threshold raised on the floor. Any hardware has to be operable with one hand, which is why we use levers and push bars. And then the closing speeds and the door surfaces are regulated. That's where I talked earlier about the bottom of the door has to be smooth. And with all that said, a local code can be stricter than the national ADA code, which is why you have to check both your local and your national codes. Some other specialty doors out there are often called a portal or a man trap, sometimes called a sally port. They use as an interlocked logic, so you enter a confined space, and until the first door locks, the second door won't unlock. And so that keeps people from tailgating, running through, bringing multiple people through. If it's a bank, for example, somebody robs the bank, they can get out the first door, but they're locked and they can't get out the second door because the teller can actually hold down a button and keep that door locked. Those are also common in prisons, any place where you don't want to escape, or data centers where you need to really control who goes in and out. Portals are a big thing. They take a lot of programming, they take a lot of planning, and they also can potentially be a fire code violation. So this is where you need to get an architect involved. You need to really make sure that the way you have the system set up is going to be compliant with the fire code. And in this particular picture here, you'll see that there's two portals, but to the right of the picture is a door that's an exit-only door. So in the event of a fire, people can crash out that door and not be trapped inside the building. Another rule is the two-man rule. And so that is, you'll see this in the movies a lot. It's probably a little bit embellished there, but basically, the two-man rule is that two authorized individuals are required for access to an area. This is common for weapons, sensitive data, things like that. And so you have to have two people that use a credential, and they have to do it. There's time-based logic, so they have to use the credentials within a certain period of time of each other. And by the two people presenting their credentials, then they're able to unlock and get to whatever that asset is. So while we're talking about credentials, let's talk about a couple different kinds. We have PIN codes. PIN codes are the same thing that you use on your ATM. The problem with the PIN codes is it's easy to steal. Also, if you share your PIN code with someone, you can never get that back. So PIN codes are a pretty low security device. Cards and fobs, those are very common. The 125 kilohertz Prox fobs are probably the most common fob out there. They have become obsolete, but people still sell them for whatever reason. They're actually more expensive than the high security credentials, but people still sell them, probably because that's what they're used to. The 125 kilohertz Prox fobs are easily clonable, as in you can go to the grocery store and use the key machine and clone that fob. If you're the owner or security director of the building, that's a huge problem. Even if you're not, someone can surreptitiously be near enough to you to scan that fob, and they can copy that fob and they can become you. So we always recommend that all systems update to a high security reader. That's going to be at least a 13.56 megahertz reader. Ideally, in addition to the higher frequency, it's going to be encrypted. You're going to use encryption standard that is either like an iClass SE, an iClass CIOS, a MIFARE, a DESFire, something like that. That's got a key that has not been broken yet. You can also have mobile credentials. These come off of your phone, be it Bluetooth or near field communication. In that case, you put your phone close enough to the reader and it's going to unlock the door. And then finally have the biometric readers. And there are a lot of different options for biometric reading. I know everybody loves the retinal scanner if they were a Batman fan from the 60s and 70s, but retinal scanners are not actually very common. That's the back of your eyeball. That's a lot harder to see. Instead, we typically do an iris scanner, which is the colored part of your eye that you can see. Fingerprints, very big. Hand geometry, which is where you slide your hand in and it measures to see the geometry of your hand against the known measurements. Facial recognition is huge, and then voice recognition. And you use voice recognition quite a bit, actually, probably if you have an iPhone, because that's how Siri knows who you are versus someone else trying to give it orders. You need to be aware that some states, Illinois is definitely one, but several other states, they require explicit consent before you can collect the biometric data from someone. So facial recognition cameras in Illinois are largely illegal because unless you have an enclosed area and you have sign off from everybody, if you have it out in the public, you're violating the law because you're collecting biometric data from people without their explicit consent. So you need to make sure that you're aware of your local laws. Let's talk about how secure they are. PIN only, like we mentioned, it's very unsecure. You can never get your PIN back if you share it. Someone sees you put it in, they now have it. Cards and fobs are moderately secure. They're much more secure if you use the encrypted credentials that we talked about. Biometric is very secure. Biometric is something that you are, so it's very hard to clone that. PIN or card becomes unsecure because the PIN makes it unsecure. But if you use PIN and card, it makes it very secure because now you have the multi-factor authentication. You have something that you have and something that you know. And then even better than that is if you use card and biometric, because now it's something that you have and something that you are. Card and biometric is the best standard for access control, especially for areas of high concern. And you get the highest security, but also the highest assurance of accuracy of the right people going in because of that being such a high standard. So let's talk a little bit about some door states. You put access control on a door, but you don't monitor it. You have no idea if that door is open or closed. So if you have no sensors on a door, just a card reader and a lock, that's great. People can use their card to get in and out, but you have no idea if that door is open or closed. So that's when we add a door position switch or a door position sensor. Those are pretty much interchangeable terms, and that tells you if the door is open or closed. So that's handy, but it doesn't tell you how the door got opened. And so then we add a request exit sensor. So if we use a REX and a door position switch, DPS, now we can see if the door is closed, and that's great, but we can also see how it got open. Was it an authorized open? Did somebody present a credential and open the door, or did somebody walk past the request exit device and so it knows it's a valid exit? Was it forced open? Did somebody use a key or a crowbar to get the door open? And then once they've opened the door, did they close it? Or did they leave it open? In that case, we have a door ajar. And so those are 4 really important states to know. When you get to an even higher security level, we also want to add some end-of-line resistors to our sensors. And so those end-of-line resistors give us 2 more states. So we still have the closed, the authorized open, the forced open, the door ajar. But now we know if someone has cut the wire and tampered with it, or if they've tried to bypass that sensor. So we actually have 6 different possible states out of that door. It makes it significantly more secure because we can make sure that we are actually getting valid information from the door. As you're dealing with doors and entry points, portals, you'll come across different types of glass. You've got tempered glass. Tempered glass breaks very easily. It breaks into millions of small pieces. This is typically what your shower doors are made out of. It's not very common to have tempered glass in a building at an entry point because it's obviously not very secure. It is more secure, I suppose, or safer than the glass that breaks into giant shards and panes, but it's still not secure because it can be easily broken. So often you're going to see a laminated glass, and the laminated glass is just sheets of glass that are glued together, usually some sort of a film or something. And so if you break that glass, it shatters, but it doesn't come apart. And so it delays entry. It's difficult to actually break all the way through. And this is the same type of glass you have in the windshield of your car. And then the most secure glass is going to be a ballistic glass or security glass. And this is the thick glass or the glass with the bullet resistant film on it that you can shoot, that you can smash, you can hit, you can take a hammer to it, whatever. And you may damage it, but it'll be minimal damage, and you still won't ever be able to break through it. This is going to be very common in a prison. You'll see these maybe in some gas stations in areas with higher crime, even some banks with areas, in an area of higher crime. But this is that really thick glass typically, or a regular glass that has some specific film on it to help make it more secure. And then once we get outside the building, outside those doors, we come to gates. And so gates are typically in the fences that go around a property, and usually have two different classifications of gates. You've got a vehicle gate, you've got a man gate. So in this picture here, you can see the man gate on the right. It's just a simple swing gate. You use your credential, use a key, whatever, you open the gate, and then it closes behind you and latches, and it will remain secure. Vehicle gates are going to come in one of a couple different flavors. You've got a swing gate. Sometimes that gate swings up, sometimes it swings out and open. And you've got a slide gate, which is also a cantilever gate. So smaller gates may only slide, larger gates are typically cantilever, whereas the gate moves, the weight causes it to shift where the balance point is, and it uses gravity to help assist open and close that gate. If you have fencing, and this is actually one of the ASIS standards that you'll read if you go through the ASIS courses, it needs to be at least 6 feet high with a 1 inch or 1 foot top guard. And so this picture here you see a 6 foot high fence, and then you've got a top guard on top of it that's actually got a little bit of a barbed wire on there. It could also just be straight wire, or if it's a high security place, it could be even a concertina or razor wire. It could also be more chain. It's just make the fence a little bit higher, but also it angles typically out of the property to prevent climbing. So people who are outside of your property aren't able to scale your fence because they can't climb over the top rail because it's angled back out, and so they don't have a way to get over it. Chain link is great because it allows us to see outside. It's not so great because it also allows people to see in. Sometimes that's nice. Sometimes we want to take advantage of the natural surveillance of the people around us, and sometimes we don't want people to know what's going on. But it is good for us because we're able to see what's going on the outside of our property. And so when we, in other classes, have talked about, the deter, detect, delay, deny, well, the detect portion there, that's where this chain link fence comes in because we can see through it and we can see people coming up. Deterrence is big here too because this is where we can start putting signage. This is where we can start identifying our property, listing out accepted behaviors, telling people, maybe we want to put a sign that says, please enter a gate with an arrow that points to the gate. Whatever. This is how we can begin controlling the behaviors of people who are coming on our property. If we do have a vehicle reader, we want that to be, if we have a vehicle gate, we want that to be secure, and we do so with a vehicle reader. So on the left here, this little puck you see, this goes on the vehicle. On the right is a reader that's a long-range reader. Typically, they can read 100 feet or so. You often don't need that. Usually, you get 10 to 15 feet, and that's good enough. And so you put the credential inside the car pulls up, the long range reader reads it, and it says, yes, that's car is okay. And so then it opens the gate automatically, the same as you would open a door with your fob if you went to your building. This is common in like a trucking place, or maybe like a waste management, where you can put these, and you can use, they make different kinds of these transmitters, of course, but you can put the transmitters on the mirrors of the trucks. And so as the trucks pull up to the waste station, the sensor picks them up and the truck can roll right on through. But if a visitor comes, they come to the wrong gate, they can't get through because the gate remains locked, and then they can follow the signage around to the visitor section. Another way to control who even gets to our building is by using turnstiles. And there's a few different types of turnstiles. In this picture, you see the full height turnstiles. And here, they only swing one way. And so this is good because it gives us some directional control. We can make these so that you can only swing them and go in, or we can make them so they can only go out. But they're hard to scale and they're more secure, but there still is a gate in the middle of them in the event people have to get out, or if you have someone coming through, maybe they're in a wheelchair or some way that they are unable to go through that turnstile. Turnstiles are great because they have a very high level of throughput. They can detect tailgating, they can detect people trying to do pass back, and so you can move a lot of people through a turnstile very quickly. Inside buildings, you often see what's called an optical turnstile, and those don't look like they're anything. They just look like they're posts sticking out of the ground, but they actually usually have some sort of a small barrier in them. And so if you try to walk through one without a credential, or if you try to tailgate, or you try to do some behavior that's not accepted, the little barrier will pop up and delay you, and then the guard that's working there can stop and challenge you and ask what's going on and help you get to where you need to be going. And then you've got the gated turnstiles, and those are the ones that they're about, waist height. They're metal. I see them most often like Menards, the hardware store, which is an interesting place to have them, but it's also a barrier. You might see them at like a bus station, right? Especially if you live in a major city. So you might see them on the transit lines. You can certainly jump over them. They're not going to stop everybody, but they are a deterrent for most people. And if somebody does jump over one, it's very obvious if they didn't go through it. So it's an easy way to see who's behaving appropriately and who's not. So we've got all this access control. Now we need to start issuing badges. And so you want to follow some badging standards. One is we always recommend that you color code your badges, so that's easy identification. If you have different areas people are allowed to be in, then color code them to the areas. If you have a lot of visitors, make the visitor badges one color different from the employee badges. Or if you have multiple companies in the same building, maybe each company gets their own colors on their badges. Just ways that a person, even from a distance, can quickly identify who that person is to the extent of where they should be. You may not be able to see the name or the picture quite yet, but at least you can see, should they even be in this area. If you give a visitor a red badge and the red badge says you have to be escorted, and you're walking down the hallway and see that person walk by themselves, it's a good reason for you to walk up to them and challenge them and say, hey, my name's Ben, can I help you find something? Right? You don't have to be mean about it, but you certainly can challenge them and help them get to where they need to be going. Recommend that you put a photo ID on there, so that way I can't give my badge to someone else because my picture's on it, and people should be vigilant enough that they would spot that the picture is different. We recommend expiration dates. Those are big. They help for auditing. So a larger company, sometimes a person gets terminated or they leave, and not all the boxes get checked, and somehow their access doesn't get turned off. So by having an expiration date, the access is going to turn off automatically. And then when they don't come back to the security office to renew their badge, then it's going to stay off. And you usually do this at 6 months or a year, and everybody understands that they're going to have, every 12 months, they're going to need to go renew their badge. I'd recommend you don't expire all the badges on the same month. Expire 8% of them or 8.33% of them each month. And so that way you split your card holders into 12ths. And in that way you're managing the amount of people that you have to renew. You could even renew some people on the 15th and some people on the 30th or things like that, right? Make sure the badges are worn in place where you can actually see them. Specify, say they have to be at chest height. Make them wear a lanyard, make them wear something that clips it to their shirt collar or to a shirt pocket. But make sure that the badges are worn above waist height, typically at chest height, so that everybody's in the same place and it's very easy to know where to look to spot if somebody has a badge. And then make sure that you're issuing a temporary badge for your visitors. Even if you're going to give them a color-coded badge that maybe has access to some places, the temporary badges are stickers that actually expire and the ink on the sticker bleeds through and it will tell you when it's void. So they generally are good for about 12 hours, and after 12 hours, ink starts to bleed through, and so a person can't get a visitor badge today and then come back tomorrow and try to reuse the visitor badge without checking in. When we talk about access control systems, we'll talk about on-premises versus cloud. So on-prem systems are just what it sounds like. Everything is there locally. It's great because you have local control. All your servers are there, but it also means that you have the internal responsibility of maintaining those servers, maintaining that data, maintaining that hardware. When you use cloud, you have remote management. You are storing it on a more secure server typically because it's a service where all they do is storage, and so they have whole teams dedicated to security. It means you're going to get better updates, more security, backups, redundancy, things you don't have to worry about that you would have to worry about if you try to store internally. The one downside is that it is a subscription based, so there is typically a cost. Very often, if you price out the cost of building your own server versus cloud hosting, it's not until 5 or 6 years into it that you actually start to see where the cloud hosting possibly becomes more expensive. And usually even then it's not, because that would be on the assumption that your server was running flawlessly for 5 to 6 years, and it probably would not. So very often cloud-based solutions end up being more cost effective and also better performing. But they're not for everybody. So make sure that if you're the end user, that you're making the decision based on your business needs. And if you're an integrator helping them, make sure that you're helping them make a decision that's the right one for their company. So when you come to access control, we have a couple different technologies or a couple different languages that card readers speak. Weigand is the oldest one, and the oldest one's probably clock and data, but Weigand is very common, but it's the older of the technologies that's out right now. It's a legacy system. It's been out for the last 20 years or more. It's not encrypted. That means it's open to a man-in-the-middle attack, which is where somebody can actually cut into that wire somewhere without they have to cut the wire. They can just clip onto it, the same as if somebody is going to wiretap a telephone line. And they can intercept that signal, and they can see what data is being transmitted, and then they can duplicate that data themselves, and they can basically make themselves look like you. It is one-way communication, so there's no authentication between the reader and the panel. It just sends the data and hopes the panel gets it. OSDP is the new technology that's out, and this standard has been out for, I'd guess probably getting on 10 years now. It's encrypted, it's bidirectional. So we talk about the one-way for the Weigand. OSDP is bidirectional. That means that you're sending data both ways, but that data is also encrypted so that somebody can't intercept it in the middle, but you also know that the data is making it where it needs to go. Because of that, it's considered supervised. And again, it's the modern standard. OSDP readers don't cost any more than Weigand readers. In fact, often they cost less. It's just a matter of configuring them in your access control system and making sure that you have an access control system that's actually modern enough to use OSDP. There are certainly a lot of legacy access control systems out there, but again, if OSDP has been out for 5 to 10 years, most of your existing access control systems that did not have OSDP are starting to become obsolete anyways, and so you can update to a system that recognizes OSDP when you update the system. The next thing that's coming out is called PKOC. It's the Public Key Open Credential. Earlier, I mentioned using formats like iClass, iClass SE, iClass COS, DesFire, MyFair, right? There's hundreds of different credential types out there and technologies out there. PKOC is trying to end that. And so what that allows me to do is I can select secure credentials, but I don't have to pick from one vendor. So currently, if I want to use iClass COS, I pretty much can only use an HID reader. PKOC is going to say I don't have to use an HID reader even if I want to use an HID technology. It's using a public and private key cryptography, and the devices actually create their own key. It's asynchronous, so it's really a unique thing. High security, but also the ability to work across multiple platforms. And it's considered future-proof because it's in development and they can continue to develop it without the legacy PKOC hardware not working anymore. Some other concepts for us to talk about: anti-passback and tailgating. I've mentioned those a couple of times. So anti-passback is I walk up to a door or a turnstile that only allows one person through at a time. I scan, I walk through, and I pass my card back to my friend, and then they scan and they walk through. So anti-passback, typically there's a time limit between when you can scan and when you can scan again. And if you scan inside that time limit, the door will not unlock. Tailgating is where I use my card and unlock the door, and I hold the door open for my friend, or I walk through, but they walk through right behind me, and so two people go through on one card. So that's going to be tailgating. Lockdown is a very big thing, especially if you work in schools. And so one of the things to talk about for doing a lockdown is what do you actually want to happen. So if I have a person in the parking lot with a gun, I will lock down my doors. Do I want to actually turn the readers off and lock the doors so that nobody can get in, or do I want to lock the doors but leave the card readers functional? And there's arguments for both. The argument against leaving card readers functional is that if you have people outside, they will try to come in, or if the person who is a threat outside is able to get a hold of a credential, then they'll still be able to get in. And so that's why a lot of schools, they actually disable the card readers themselves. The downside, of course, is that that also means that the police department can't get in because their credentials also will not work. There are a lot of systems that allow you to pick which credentials are affected by lockdown, which ones are not. But I don't know if that's as common now as it hopefully will be. And then policy enforcement. Access control systems, security in general, you can have all the best systems in the world. If you're not doing policy enforcement, if you're not making sure people wear their badges, not preventing doors from being propped open, not addressing, false alarms, not addressing system issues, then people are not going to comply with your security policies. So policy enforcement is very big. And then one of the last things to think about is system integrations. So older systems, the integration was really just some relay logic. Now, any professional integrator is going to sell a system that actually has an integration to other types of systems, and it's in the back, it's on the software side. So you don't have to do the wiring together, right? They're all going to reside in the same network. They're all going to be able to communicate back and forth. Instead of just being a simple door unlock, now we can queue off a lot of other events. For example, maybe I have a guard that watches my cameras 24 hours a day. Well, if I have a vehicle gate that he needs to sometimes open, I can make it so he can unlock that gate through the camera, so he never has to move away from the camera screen. He doesn't have to go to a different computer. He doesn't have to flip to a different program. He stays in one single pane of glass watching that camera, and he controls that gate through there. Another one is sending a video clip on a certain access event. So if I have a person try to access a secure area that they don't have access to, maybe I'm going to quickly send a video clip to my guard force so they can take a look at it and see what's going on. We have the intercoms that can unlock a door. And so in the past, they typically had to be wired together, but now we can do that through the back end. And because we're able to do that through the software, I now have a log in my access control system that the intercom was used. And so one of the first questions we ask is, can we can we go back and see what happened? And so that's where the integration with an intercom, not just a wire connection, but the actual integration is huge, because now I have a transaction log. We can do things like we can prevent entry by a card reader if the alarm system is armed. And so this is important if you have a building where not everybody has an alarm code. Maybe only the foreman or the supervisors have alarm codes, right? So if you get other people that show up early, they can't get into the building because the system is still armed, and if they were to go in, they would set the alarm off. And then a big one that we see too, especially for larger installations, is automatic database updates. This is huge for apartment complexes. This is huge for companies that have a lot of employees and they use Azure or a similar database, and they can actually update their card holders, update their managers through that. And so now when they terminate an employee, they don't have to remember to check all these boxes. They terminate the employee in Azure or whatever system they're using, and that pushes it all the way down, takes their access control away and everything else. So in closing, access control is really about trust, accountability, and controlled movement through a space. Trust is that we're allowing people that we want to be in there. We trust them to do the right things. But also people who don't want to be there, we have someone who we trust with them. And then it's a matter for employees of trusting the system that's working. So that goes back to, if they see doors are propped all the time, if they see sensors don't work, things like that, they begin to not trust that system, and then they stop using that system. It's also about accountability. If I have a log of everybody that enters a room, there's less likelihood that somebody's going to do something malicious in there because there's a record that they went in that room. And it's all about the controlled movement through the space. So as soon as I go from the unsecured side of a building, from the outside or onto a property, I want to control the movement of my people and my guests, so they're only going the places they're supposed to be going, only doing the things that they should be doing, and not going to the places that they shouldn't be. And that's it. Thanks for listening, and have a great day.
Welcome to Vigilant Security Consulting.